This is the 6-1 to 6-3 review. Calculators are not allowed, and it's number 2. On this one, we are finding areas between curves. So this is a 6-1 problem. First part says the region enclosed by the curves y equals x cubed, y equals x, x equals -1, and x equals +1. So our first goal is to draw the picture. So I'm going to do the axes in pen. Then I'll do the curves in pencil. And it looks like x equals -1 and x equals +1. So we don't even really need those lines because we have the intersections already. So we can see that it intersects at -1, -1, at 1, 1, and then again at 0, 0. So we've got two distinct regions here, but because of the symmetry of the curves, we can deal with just one of them and then double it. So let me move this up here so we have more space to label our red strip. So our strip will be, I'm going to choose to go vertically since I've already got y isolated. And the bottom one will come off of the x cubed curve, and the top one is going to come off of the x curve. So now if I draw my representative slice, which is a rectangle, the width is going to be dx, and the height is going to be x minus x cubed. So now if I write my integral, it will be the accumulation of that height times the width times 2, and we'll go from 0 to 1. So if I do that, I don't have a calculator, so I got to finish it up by answering the question, what did I take the derivative of with respect to x that gave me that inside? And the answer is an x squared over 2 minus x to the 4th over 4. I'll evaluate that from 0 to 1, which means I plug in the 1 first, and then I plug in the 0. So a half minus a fourth is a fourth, times a 2 gives me a 1/2. Okay, next one. Same issue, same thing. We'll draw the axes in blue. And then the curve in pencil. So looking at this, it's going to be a little tricky because we see that we have an x equals something instead of a y equals something. So we have to be thinking sideways. Now, to help ourselves, just like if we had x and y switched, we can look for the zeros on that cubic to understand how it's going to open and how it'll move through those zeros. So I'm going to factor this first, and I'll pull out a y, which gives me a y squared minus a 2y minus a 3, which in turn will factor into y times a y minus a 3 and a y plus a 1. So I can see that when y is 0 or 3 or -1, I'm going to have intersections on the curve. So 0 or 3 or -1. So now we have to decide how this curve opens. Does it go through like this, or does it go the other direction? Well, how we can tell is as y gets big, this term will dominate. So this positive term is going to have more of an impact on the output, which is x. So that means x is going to be positive as y gets higher. So as we pass this point, we got to be heading toward the positive. So our graph is going to do something like this. So the region enclosed by the y-axis and that curve looks like this, which means we've got two distinct regions. So we're going to have two strips, and each of them need to be labeled with y's because we have cut horizontally. So they share a y coordinate. This x coordinate is 0. This one the x-coordinate comes from the curve. So we'll have a y cubed minus a 2y squared minus a 3y, comma y. This one comes from the axis, so that's y0. And this one comes from the curve. So y cubed minus 2y squared minus 3y, comma y. So for this first strip, its length is dy, and its width is 0 minus this. So that means I'm going to change the sign. So that'll be a negative y cubed plus a 2y squared plus a 3y. For this second strip, the width is still dy, only this one, the height is the right minus the left. So it's a y cubed minus a 2y squared minus a 3y. So if I set up my integrals now, I will integrate from, notice these are y set up, so it's going to be y limits. I'll go from 0 to 3 on this one. So width, or length times width. And this one will be from -1 to 0. So I'm going to add these two areas. So both of them I'll need to get the antiderivatives. So that's a negative y to the 4th over 4 plus a 2y cubed over 3 plus a 3y squared over 2 from 0 to 3. And same thing here, I'll have a y to the 4th over 4 minus a 2y cubed over 3 minus a 3y squared over 2. And this one goes from -1 to 0. So the zeros aren't going to give me anything. So if I plug in the 3, I get a -81/4 plus an 18 plus a 27/2, and then I have minus a 0. And then this one will give me 0 minus the thing with the -1 plugged in. So with the -1 plugged in, I get a 1/4 plus a 2/3 minus a 3/2. So if I get a common denominator on all of these, it looks like I'm going to need a 12, maybe. So if I put that all together, I will let you crunch through the arithmetic, and I don't think on the test that the arithmetic is quite as horrific. We'll end up with 71/6.